Hey guys, and welcome to the first lesson in a brand new chapter of your math career. This chapter is going to focus on finding unknown side lengths and angles in right angle triangles. So, given some information, we're going to be able to find the length of some unknown side. So, the first thing I want to talk about is it says right angle triangle. Well, let's just remember the right angle is right here. What does a right angle mean? It means it's 90 degrees. That's all it means. So every time you see the little box or it says right angle, we know that this one right here is 90 degrees. Now, directly across from the 90 degrees, or I should say opposite this 90 degree angle, is a familiar word for you, I hope. Hypotenuse. Now, hypotenuse means the longest side of a right triangle. You can also say that it is opposite the 90 degree angle. Where else did we see this word? Well, something else we know about right angles is the Pythagorean theorem. A squared plus b squared is equal to c squared. This theorem is still true. It always will be. But here we were doing something just with side lengths. We had two side lengths and we were asked to find the third. So maybe it was those two, maybe we had these two and we're asked to find the third, or maybe it was these two and we were asked to find the third. Either way, it was all side lengths. The new thing here is that we're going to use one side length and an angle. And we're going to call this angle, just by convention, theta. So theta, it's like a big O with a line through it. Theta is just the symbol that we use to represent the angle that we're interested in. So I'm going to call it the angle of interest. So just to say, at any point in the problem, we might be looking at any of the angles, but whichever one we're using, that's the one we'll call theta. And we need to know which one we're using and remember it, because everything that we do is going to be relative to this angle. So we call this process trigonometry. Trigonometry is a big old math word that means we're going to look at the relationship between angles and side lengths of a triangle. So we're going to use theta to help find these missing side lengths. And we need one of them to get started, and then we can find the other two just using theta. First, let's name the sides. So remember, everything's relative to theta, but there's one that it's always the same, and that is the hypotenuse. So the longest side here, the one that is opposite the 90 degree angle, that's the hypotenuse. And that word opposite is very important to us because it is our next side's name. So opposite the 90 degree angle is the hypotenuse. Opposite the angle of interest, the theta, opposite that one is what we will call our opposite. So let's write that in. Excuse my messy sideways writing. That's going to be our opposite side. Opposite to what? To theta, right? If theta was up here, its opposite side would be down here, but it's not. Right now, this is our theta. So, if you're facing your partner, if you're looking someone in the face, you're standing opposite to them. What about the person you're sitting next to? The person you're sitting next to right now is somebody that you are adjacent to, and that is the sort of mathy word that we use. Adjacent. For the side that is beside theta. Note that the hypotenuse is also next to theta, but it's already the hypotenuse, so it doesn't need another name. So we have opposite, adjacent, and hypotenuse. And adjacent just means, look it up in the dictionary, it just means it's beside it. It is adjacent to theta. So that's what I mean by everything is relative to theta. The side that we call opposite is opposite to our angle, theta. The side that we call adjacent is adjacent to our angle, theta. So these are our players. We're going to use them to find some very cool things, to find some ratios. So what is a ratio? Well, a ratio is a fraction or division. Anytime you do one of those things, you're creating a ratio. And a trigonometric ratio, so trigonometry means we're talking about angles and side lengths of a triangle, is a ratio that deals with side lengths of a triangle. So in this case, all the ones that we're going to talk about today only apply to right angle triangles. If it's not a right angle triangle, then that's not what we're talking about. So that's very important, right angle triangles. Okay, look at your calculator. Somewhere on that calculator, there is a button that says SIN, and then maybe there's an X, or maybe there's another symbol, but SIN is the button. This is your sine button. So it's actually, the word is with an E, but when we do it like this, we take away the E. So our sine is our first trigonometric ratio. The first thing we need to do before we talk about anything is decide where's theta. So for this example, let's say theta is this angle here, bottom right, which would mean that this is our adjacent. I'm just going to write small letters here, 3 letters. This is our opposite, and this is our hypotenuse. Right? Everything's in terms of theta. So the sine of theta is going to be equal to the opposite side length. So the length of the opposite side divided by, or over, the length of the hypotenuse. So in short, so we're just going to write that again the way we do as we solve problems. The sine of theta is equal to opposite over hypotenuse. This is our first trigonometric ratio. Very important. And very simple. There's just 3 values. This angle, the length of the opposite side, so whatever it is, it'll be in centimeters, meters, just a length, and then the length of the hypotenuse. Given that you have 2 of them, you could find the third. So let's see this in action. Here's a triangle. We're given an angle, and we're given a length. What length is it? Well, it's of the hypotenuse. So we have theta, and we have the hypotenuse. The unknown that we're going to look for is the opposite. Well, perfect, because the trigonometric ratio that we have, sine of theta, is equal to the length of the opposite over the length of the hypotenuse. So we can just sub in what we know here. Sine of 35, and on your calculator you can punch the button sine and it'll open up a bracket for you. Put in 35 and close the bracket, and that's it. Is equal to the opposite, that's our unknown, over the hypotenuse, which in this case is 5.6 centimeters. So we have an equation with an unknown. This is just a number. This is just a number. So an equation with an unknown, how do we solve that? Well, we try to isolate the unknown variable. So what's the opposite of dividing by 5.6? Multiply both sides by 5.6. and we're left with 5.6 times sine of 35 will equal our opposite value. If you punch sine of 35 into a calculator, as you should be doing right now, you're going to get some value 0.57 dot 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 dot. What I would say is try and keep this number in your calculator. Don't write it down and then use a shortened version or a rounded version. Keep the full length number and then just multiply right away by 5.6. So you can type this whole step into your calculator. 5.6 times sine of 35. Just remember to close the bracket there. So when you do that, you're going to get an answer. And in this case, you should get 3.212 equals the opposite. So what does this mean? It means the opposite side of this angle theta is 3.212. What was the unit? Centimeters. So there you go. Let's see the next one. Right next to your sine button, there's probably another one called cosine. So cosine, very similar. Let's say this is our theta. Right, we could use either one of these, but we'll just say this one because it's easy. If that's theta, well, this is still hypotenuse. That isn't affected. But across from our theta is our opposite side length, and beside it is our adjacent. What the cosine of theta, what that ratio will equal is the adjacent side length. Oh, I should write this out in full. Cosine theta is equal to the length of the adjacent side divided by the length of the hypotenuse. So in short, and this is how we'll write it when we solve problems, the cosine of theta is equal to adjacent over hypotenuse. Just remembering that these mean the length of adjacent and the length of the hypotenuse. These are just numbers. So this is our second of 3 for today, trigonometric ratios. So let's see this in action. Here we have an angle again. It's 42. This will be our theta. We're given the hypotenuse. We're asked to find the adjacent side length. Perfect. We know which one to use. The cosine of the angle, any angle theta, is equal to the length of the adjacent side over the length of the hypotenuse. So now it's a matter of putting in our numbers. So cosine of 42 will equal, adjacent is our unknown, and hypotenuse is 3.2. So just like before, we're solving for one unknown variable. This is just a number, this is just a number. So we can rearrange, multiply both sides by 3.2. And we can solve for our adjacent side length. So type this all into your calculator. Cosine of 42 will come out to be 0.743, yada, yada, yada. But keep all those decimals so that you get a final answer. When multiplied by the 3.2, you'll get 2.378. What does this number mean? Well, it's the adjacent side. What about the adjacent side? It's its length. So the length of the adjacent side is 2.378 centimeters was the unit. And there you go. So we've done opposite over hypotenuse. We've done adjacent over hypotenuse. The only other combination is between the opposite side and the adjacent side, And that's exactly what our third trigonometric ratio is all about. So tan, short for tangent, the tangent is tan of theta, I should say, is the opposite, the length of the opposite side divided by the length of the adjacent side. So there you go. And it works just like the other two. So we can write it out sort of in our short form here. This is how we usually write it just in our work. So tan of theta is equal to opposite over adjacent. And there you go. This is our third and final trigonometric ratio. So our third ratio, our third division that helps us find missing side lengths of a right triangle. So let's use this one here. I'll just get this out of the way. Didn't leave myself a lot of room. Let's use this to solve for an unknown here. So now we're given this angle as our theta. We're given the opposite side's length, and we're asked to find the adjacent side. So the tan of theta, as you can see here, well, perhaps we can just put our numbers in right away. The tan of 36 is going to equal the opposite, which is 10.1, divided by our adjacent, which is our unknown. Perfect. We have one unknown variable and two just numbers. So, knowing your rules of proportions or your rules of fractions, you can see that rearranging this, we would get the adjacent is equal to 10.1 over tan of 36. If you don't remember those rules, just see, we can just use BEDMAS again, multiply both sides by adjacent, and then adjacent will be on this side. Divide both sides by tan of 36, and it brings it back down. But knowing our rules, we don't need to show that step every time. So now we can just solve by plugging this into our calculator, and we'll get a value of 13.90. The unit here is in meters. And this means that our adjacent side, the length here, is 13.9 meters. So not too complicated, as you can see. It's just a matter of choosing the right one. So here, this is how you're usually presented. It's not told, here use sine, here use cos, here use tan. You have to decide which one is appropriate. So let's see what we have. Here is our theta, down at the bottom right. So we have our theta. This value here is our hypotenuse. And this value here is adjacent. So look back at the notes you just took. Which of those three trigonometric ratios is appropriate to use here, given that we have adjacent and hypotenuse as our players? Well, you should see that cosine of theta is adjacent over hypotenuse. So this is the one to use, cosine. If we use sine, well, that's opposite over hypotenuse. We're not interested in that, and it's not given, so it really doesn't come into play here. So this is what I mean by choosing the correct trigonometric ratio. Once we've done that, well, then it's just a matter of subbing in our values and solving for the unknown. So the cosine of 29 is equal to the adjacent side, which is our unknown, divided by the hypotenuse, which is 7.2. And now we can solve. So multiply both sides by 7.2, and we'll get 7.2 times the cosine of 29 is equal to the adjacent side. Punch this into your calculator, and you will get 6.297. This means that our unknown, our adjacent side here, has a length of 6.297 centimeters, in this case, was the unit. So that's the extra mental step we have to put in. Just decide which trigonometric ratio to use. Luckily, there is a very easy way to remember all of them, and that is the most famous expression in math, SOHCAHTOA. SOHCAHTOA. You will hear this for the rest of your life. It will enter your dreams. So would mean sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. So it goes in order. And TOA, tan of theta, equals opposite over adjacent. So that's the nice thing about these. Very easy to remember. SOHCAHTOA. SOHCAHTOA. Say it 10 times. Say it at the dinner table tonight. People will think you're crazy, but really, you're a trigonometric genius. So, what do we do with all this? Well, a very common question that you might be asked is solve the following triangle. When you see this expression, solve the following triangle, solving a triangle means finding the missing side lengths and the missing angles. So find out basically all the measurements that have to do with this triangle. So again, we have to make choices. Let's start by just finding where is theta, what is theta. So here our theta is the one that we have, 65, so right here. If this is our theta, then that means the value given here is it our hypotenuse, our adjacent, our opposite? It is our adjacent. It is beside it, but certainly not the hypotenuse. The hypotenuse is down here. So directly across from theta is our opposite side. So this is what we need to find first. So we have some choices here, because here's theta, we're given adjacent. 2 out of those 3 trigonometric ratios use an adjacent side. So we could solve for either the opposite or the hypotenuse first. So it doesn't matter, but I'm going to solve for the hypotenuse first. So that means I need adjacent and hypotenuse. Which one is that? Well, that's cosine once again. So the cosine of theta is equal to the adjacent side's length over the hypotenuse side length. So cosine of our theta, 65, is equal to our adjacent, which is 12, over hypotenuse. We can solve for hypotenuse, 12 over cosine of 65. Punch that into your calculator, and you'll get 28.39 centimeters. So already things are going well. We have 2 out of the 3 side lengths. Now you might ask, oh, 2 or 3 side lengths. You said when we have that, we can use our Pythagorean theorem. Yeah, totally you can. Or you can use the trigonometric ratios. It's all going to work out to the same answer. So given this, I'm going to use another trigonometric ratio. I have hypotenuse, I have adjacent, and I'm looking for opposite. Well, opposite has to be involved. Okay, opposite has to be in the ratio that I'm going to use because I'm looking for opposite. So that leaves me, I can use sine of opposite over hypotenuse, or I can use tan, adjacent over opposite. So sine or tan. So I'm just going to use sine, either one, you'll get the same answer. Sine of the theta, 65, is going to equal the opposite side over the hypotenuse. So now I could sub in my values. Sine of 65 is equal to, opposite is our unknown. Hypotenuse we just found, it's 28.39. And so if I rearrange to solve for opposite, I'm going to find that I get 28.39 times the sine of 65. And so the opposite side length here is 25.734. And that's it. We found all three sides. Now, are we done? Well, no, actually. Because when it says solve, and this is important, what the word solve means to the Ministry of Education is find the side lengths and find the angles. So we need to find the mystery angle here. Well, the good news is we don't need to do any fancy trigonometric ratios to do this. We'll do it down here. Remember, a property of triangles is that if you add up all of these sides, if you add up this angle here, let's call this angle A, let's call this angle C and B, ABC. If you angle A plus angle B plus angle C is going to equal 180 every time. So we're just going to use this property because we know 2 out of the 3 angles. What? We're only given 1. No. This is a right triangle. So we are given 2. So we can find this angle A, we've just called it, 180 minus 90, that's our first angle, and then subtract our next angle, 65, and we get an angle of 25 degrees. And so that's all we need to do to find our last angle in this scenario. So I hope you enjoyed this little lesson, this intro to trigonometry. We could find any missing side length just by given an angle and any one of the other sides of the triangle. I'll see you in the next one.